I wanted to say thank you to Ritzy for organizing this because he put it all together at the last minute, and I am really happy to be here. So thank you, and thanks to all of you for coming. I now teach at the University of North Carolina at Chapel Hill, but many thousands of years ago I was an undergraduate in Scotland at the University of St Andrews, so this does feel like coming home a little bit. Okay, so I am going to be talking about a topic in the philosophy of logic. Logic tends to be a pretty technical topic, but I think this is a talk that you will be able to understand even if you don't have a lot of background in logic. So I will be putting various formulas on the board as examples in some circumstances, but it's often not going to matter if you're not familiar with like these symbols or these ways of putting things. So don't be put off by that, at least not too early. So my topic is logical nihilism, which is the view that there are no laws of logic whatsoever. It's a view that would fit in pretty naturally on the spectrum that includes views like logical pluralism and logical monism. So logical monism has been the traditional view for many, many years, and it's the view that there is one true logic. There's one theory that tells you which arguments are logically valid, which logical principles hold, and that's kind of the end of the story. So for some people, that's classical logic, for people like Timothy Williamson or Quine. For some people, that might be a weaker logic like intuitionistic logic or strong Kleene logic. For some people, it might be some kind of paraconsistent logic that includes true contradictions. So Graham Priest is somebody who accepts that kind of logic. But what all those people have in common is they think there's one logic, and the logic they like, that's the one. Logical pluralism is a more recent view, and I think a lot of people thought when the view first came out that it was really hard to see how it could be true. So logical pluralism is the view that there's more than one correct logic. And the people who defend it sometimes get at this idea by this. They say, well, if you look at an argument, like maybe disjunctive syllogism or modus ponens, and you're interested in whether or not that argument is valid, sometimes the answer is yes, it's valid. And sometimes the answer is no, it's not valid. And here's how they kind of explain this view. So what it is for an argument to be valid is that there are no cases in which all the premises of the argument are true and the conclusion is not true. And they say that's just the intuitive content of entailment, of logical consequence, of validity. But it turns out that this word case is a bit vague. Right? So when you ask, are there any cases in which all the premises are true but the conclusion's not, the answer can depend on what you mean by case. And they say there are different ways you might make that expression more precise. Some of those ways look a lot like the models for classical logic. Some of those ways allow you to have like true contradictions, and so you can get counterexamples to certain classical principles of logic. Some of those cases might turn out to look a lot like incomplete models, and so you get counterexamples to things like the law of excluded middle. But since there are various legitimate things you could mean by case, there are various legitimate disambiguations of this expression valid, or of logical consequence, or of entailment, and so there are different correct logics, the ones that are different specifications of those expressions. Okay, so if you hold that kind of view, you end up being a logical pluralist. You think there are many correct logics. And then the nihilist is just the person that thinks, yeah, both the monist and the pluralist are wrong. There's no correct logic. So that means that all the logical principles that are a little bit controversial, right? So maybe the law of excluded middle, that for any sentence, either it or its negation is true. They're going to say, yep, that's not right. Or this one, the principle of non-contradiction, that it's the negation of the conjunction of any sentence with its negation. Right? That's always true. They're going to say, yep, that's not right either. Right? There are situations where this can be false. Or, and maybe this is even more intuitive, something like modus ponens. Right? So this says you have a conditional, if phi then psi. Phi, therefore psi. Right? So an instance of that would be something like, if snow is white, then grass is green. Snow is white, therefore grass is green. Right? Seems like a logical argument if anything does, but the logical nihilist doesn't think any logical principles hold. So they're like, nope, not that, not explosion, not all the controversial things, but also they have to say it about the things that nobody disputes, that aren't controversial to anybody. So one example might be, say, conjunction elimination. The principle that from phi and psi, you can get phi. Right? That's so boring that nobody disputes that one. But the logical nihilist has to, because they think there are no logical principles that hold. Okay. So this view sounds very radical. Usually when somebody disputes, say, a principle in classical logic, and they say, for example, okay, it's not true that you can get anything from a contradiction, then they're often at pains to keep their logic strong in other respects. So they might say, really hang on to the law of excluded middle, even after getting rid of the principle of non-contradiction, because they know that if they get rid of the law of excluded middle as well, the resulting logic is very weak. And there's a tendency to not like very weak logics, to sort of worry that your logic might get too weak and that that would be a problem. And logical nihilism is going to be right at the end of that problematic spectrum. It's the weakest logic, the logic on which no principles hold whatsoever. So given that this view seems so undesirable, so crazy, so beyond even controversial, you might wonder, why would you want to think about it? Why would you want to talk about it? Well, one reason is that it has kind of come up in recent discussions about logical pluralism. So there's a sort of discussion, a sort of thread of debate that goes on when people are talking about logical pluralism that starts out by saying, well, you logical pluralists, you think that modus ponens is right when you're thinking about some kinds of cases, but not when you're thinking about other kinds of cases. However, that just shows that you've misunderstood what a logical law is supposed to be like. Because logical laws are supposed to work in every case. Right? It doesn't matter what kind of case you're thinking about. So if there are some cases where these logical laws don't work, well, then they're not really logical laws. And the monist who takes this kind of line about logical pluralism, they think there's a way to kind of recover the one true logic from the logics that the pluralist accepts. So the pluralist might say, well, if you're thinking about these cases, then you get classical logic because all of these arguments, the ones in this circle, they're the valid ones. And they might say, okay, but if you're looking at paraconsistent cases, then maybe only a subset of those arguments come out valid. And if you're looking at paracomplete logics, well, maybe it's a different subset of the classical logics. But there are three different logics. There are three different sets of valid arguments. So there you go. And the monist has said, well, no, it's only the arguments that always work that are really the logically valid arguments. So they are saying, okay, so here's your one true logic. It's the arguments that are in all of these circles that you accept at some point. Right? Because these ones get accepted at all times. Okay, so now the pluralist answer to this is important and interesting. They say, there is nothing in this space, right? If this is the argument you accept, if you think you can recover the one true logic from like all the acceptable pluralist logics, there's nothing left. Because every principle fails in some cases. Okay. So they've given us just a sort of sketch of an argument that ends in logical nihilism. And I'm calling this a sketch of an argument because lots of the stuff that's in it is a bit vague, it's a bit unclear, but just, keeping this as a sketch for now, there's a first premise that is this commitment to generality in logic, that in order for an argument to be logically valid, it has to hold in absolutely every case. Okay, so let me put it this way. For a principle to be a logical law, it has to hold completely generally. So that's the generality premise. It encodes the monist commitment to generality. And then premise 2 in this argument says no principle holds completely generally. And then the conclusion is, okay, so there are no logical laws. Okay, that's an argument that finishes with logical nihilism. It's an argument that the logical pluralist has put forwards. They don't mean it to be an argument for logical nihilism, right? They take this to be a reductio ad absurdum, right? They say, if you accept this and you accept this, you end up with this absolutely ridiculous view that there are no logical laws, so you better reject one of these premises. Now, most of the people involved in this debate, they're used to thinking about lots of different kinds of logics and looking at all kinds of different counterexamples. And so a lot of the pluralists find it fairly plausible that no principle holds completely generally. At least that's what they start out by saying. And then sometimes they say, oh, except for a few boring ones. Right? And sometimes when they list the few boring ones that you might get, they do conjunction elimination. So from phi and psi, you can get phi. They sometimes mention identity. That is, that everything entails itself. And then once I've heard thinning mentioned. So thinning's actually on the board down here. It says, if you have a good argument in which a set of premises gamma entails phi, then if you add something new to the premises, you still have a good argument. So they say, okay, you get to keep those things, but that's not logic. That's so weak that it's barely interesting. So practically, no principle holds completely generally. And since you don't end up wanting to say that either there's no logic or it's super, super weak, the pluralist thinks that you should get rid of this generality commitment. The commitment that says, to be a logical law, it has to hold completely generally. But that only works as a reductio if you accept that the conclusion is completely ridiculous. That logical nihilism is a view nobody would want to hold, and as soon as you have an argument for this view, well, you better get rid of one of the premises. And the whole way in which this talk is set up, we're not going to assume that logical nihilism is completely ridiculous. And what I'm going to be doing with this talk is, first of all, talking about sort of exactly what logical nihilism amounts to. So I've said a little bit about what it is. It's the view that there's no logical laws. But you can get clearer on exactly what that means by saying, exactly what a logical law would be and what it would be for something of that kind of form to be correct. So I'm going to talk a bit more about what logical nihilism would actually amount to. And in doing that, I'm going to try to make it seem to you that logical nihilism is not absurd. That it's actually another possible view on this spectrum that has pluralism and monism on it, and not one that we should obviously give up on right away. I'll talk, first of all, about why I don't think it's self-defeating, which is sometimes something sort of criticism you hear about it. But later, when I get into looking at exactly what the view would be, I think that I can also deal with like a different kind of worry that you might have about it, where you just think, I just don't see how logical nihilism could turn out to be true. And then I am going to give you kind of a sketch of an argument for logical nihilism. Right? So I will produce some counterexamples to common logical laws and suggest to you that this is sufficient to make nihilism plausible. So there'll be something like an argument for logical nihilism. And then the last part of this talk, I'm going to talk about what we should do about it if this argument turns out to be good. Like, what is the sensible response to these kinds of worries and these kinds of things? And what I'm going to try to persuade you is that an approach that Lakatos took in the philosophy of mathematics when he was thinking about geometry made a lot of sense in that case, but also makes a lot of sense when we're thinking about logic and the epistemology of logic. And in fact, we should adopt that work in this case. So here I'll be talking about Lakatos's view, Lemma Incorporation. So I suppose in a way I'm going to create the problem and then I'm going to tell you how to solve it. Okay, so first part, on logical nihilism, why it's not so scary, why it's not self-defeating. Here, I think, is the heart of the objection when people say logical nihilism is self-defeating. They're thinking logical nihilism is the view that there are no valid arguments. So if somebody gives you an argument for logical nihilism, on their own view, it can't be a good argument. Right? It can't be logically valid. So that seems to undercut, like the view itself seems to undercut the argument for the view. And in that sense, you might think it's kind of self-defeating. Okay, I don't think this objection works for a variety of reasons, but probably the most important one to see is that arguments can be good in all kinds of ways, even when they're not logically valid. Right? So it could be that pretty much always when the premises are true, the conclusion's true. Right? Or that the truth of the premises gives you really great epistemic support or even semantic support for the truth of the conclusion, such that even though the argument is not logically valid, it still gives you really good reason to believe the conclusion. In addition to that, there are all kinds of good arguments that don't even pretend to be deductively valid. Right? There are inferences of the best explanation. And if somebody gave you that kind of argument for the conclusion that there are no logically valid arguments, that wouldn't be self-undermining. Finally, if somebody gave you a classically valid argument for the view that there are no valid arguments, that ought to be seriously worrying to somebody who accepts classical logic, right? So the argument might create trouble for somebody who does think there are valid arguments, right? Even if it's sort of using the nihilist opponent's own tools against them to kind of undermine the view that, say, classical logic is correct, or that some weaker logic is correct. So then, maybe to reinforce that first point, let me talk about one reason you might think that you kind of just can't see how modus ponens could fail, right? So when I write down certain instances of modus ponens, I find them absolutely compelling, right? If I use if snow is white, then grass is green. Second premise, snow is white. Conclusion, grass is green. Okay, so there's an instance of the argument form modus ponens. We've written snow is white in for phi, grass is green for psi, and it seems to me that it's impossible for the premises to be true and the conclusion false. Right? I think given what the premises mean and what the conclusion means, it can't be that the premises are all true and the conclusion's not, that is not enough to give me modus ponens. Right? The perfection of this argument, if you like, is not enough because modus ponens is much more general than that. It says not just for this instance, but for every instance of modus ponens. If all the premises are true, then the conclusion is as well. So that means no matter what I write in for snow is white here and grass is green, the argument has to come out right? It can't come out with true premises and not a true conclusion. And now I think about, okay, realizing that modus ponens is that general, how confident am I that there are no counterexamples? That whatever I write in there, this is going to come out right. And now I start to think, well, it's turned out that language can get pretty complicated. Right? The snow is white case is kind of boring, but there are all these things that have made people revise logics to do with things like, well, what if there are vague expressions in your language? What if there are expressions that fail to refer to things? What if you have all kinds of special semantic predicates that get you into various kinds of paradoxes? What about where you have context-sensitive expressions and different things turn out to be valid than you might have expected? Am I confident that for any sentence, no matter how rich the language, if I wrote it in here, I wouldn't have true premises and a non-true conclusion? And because the claim is so general, because it's so strong, I'm not sure. Okay, so the thought there is you can be a logical nihilist and still accept there's nothing wrong whatsoever with this argument. Right? You can even think that semantically, given what the two premises mean, that guarantees the truth of the conclusion, that it's sort of semantically valid, without thinking that it's logically valid. Because to think it's logically valid, you have to think that form has no counterexamples. Right? And that's a really strong claim. Okay. That seems to open up the possibility that logical nihilism might be true. Right? Doesn't seem so ridiculous anymore, but it's one thing to say, yeah, it could turn out to be true, it's not completely ridiculous. It's another thing to actually give an argument for it and show somebody that, it's a sensible thing to think, right? There are lots of coherent, reasonable views that are just false. Okay, so here is kind of in the second part of this talk, some thoughts about why somebody might think that logical nihilism is correct. Sorry, I've got a little bit more to do in the first part. Let me go back there. So the other thing that I said I would do is I would talk more about exactly what logical nihilism is going to amount to. And actually there's two things that I want to do there. One is I want to talk about the form of logical laws, like what they're supposed to look like syntactically. So like what counts as a logical law. And secondly, I want to talk about what it takes for something of that form to be true. Right? Since logical nihilism is the view that nothing of that form is true, right? That will clarify what the view amounts to. Okay. Now, it might seem as if it ought to be obvious what a logical law is, but in fact, there is all kinds of controversy about this kind of thing once you get into the philosophy of logic. But one view that you sometimes come across is that things like these top two principles here, where you have like the entailment predicate and then some schema follows it, that's what a logical law looks like. So the paradigm cases here would be things like the law of excluded middle, phi or not phi, and the principle of non-contradiction, so not phi and not phi. But it doesn't seem like a good idea to say that logical laws are all and only things that look like this, where you have nothing on the left-hand side of the turnstile. Because there are some logicians who accept logics on which there are no principles like that. But they don't seem to be logical nihilists. So one example would be a strong Kleene logician. Strong Kleene logicians think that, they think logical consequence is a matter of truth preservation, as like a lot of people do. So there have to be like no circumstances in which all the premises are true and the conclusion false. So if it's a principle like this, it has to be impossible to make it false. Right? But on the other hand, they think that there's a third truth value. There is true, false, and neither. And if one of these things turns out to be neither, then its negation is neither as well, and then the disjunction of two things that are neither, that turns out to be neither. Neither's not true. So you have a counterexample to the law of excluded middle, and moreover, you get counterexamples to all the classical logical laws of this form. But you don't get counterexamples to modus ponens, and you don't get counterexamples to disjunctive syllogism or conjunction elimination. In fact, all the classical principles where you have something on the left, you don't just have an empty set here, they still hold. So the strong cleaning logician doesn't seem like a nihilist, right? They accept things like modus ponens, but they don't accept anything of this form, and if what we meant by logical laws was things of this form, they'd end up getting classified as nihilists, which is silly, right? So there's an obvious solution. You say logical laws can either look like this, or they can have some stuff on the left-hand side like this. Presumably what you say is, a logical law is something of this form, where gamma is some set of sentences, and phi is some sentence, and gamma is allowed to be empty, that's fine. So you can get that case as well. So that seems like a good solution to that problem, but if you've done much logic and you thought, well, we've got these principles and we've got these principles, you might wonder about some more complicated principles as well that go beyond these sentences where the entailment symbol is the main predicate and like actually connect these things. So for example, here's thinning. If gamma entails phi, then gamma and psi also entail phi. Or this is one version of cut. So if gamma entails phi and delta and phi together entail psi, then if you have gamma and delta, that entails psi. And it's like the transitivity of the entailment principle. I am not going to count more complicated things of this kind of form as laws of logic. So that means if I say there are no laws of logic, I'm actually not denying that things like this hold. Okay? So I'm just going to like cross these off right now, things of this form, as laws of logic. Here's why I'm not going to count things of this form as laws. It's because I basically think the logical nihilist thinks that the entailment relation is empty. Right? That for any set of premises and any conclusion, the logical nihilist thinks those premises don't entail that conclusion. Right? So if you drew all the arguments on the board and you were asked to put a circle around the valid ones, right, the nihilist says it's the empty circle. Right? There's nothing in there. Okay? But you can think this relation is empty, and then for trivial reasons think that principles like this are true. Right? So this says if gamma entails phi, then gamma and psi entail phi. And I say, well, this always holds. Like, this never holds. Right? So the whole conditional is just trivially true. Right? So I can be a nihilist and accept thinning. Right? I just think that antecedent is never met. Right? All right, so that seems like nihilism enough to me. Right? Yeah, so you accept thinning, but only because the antecedent to this conditional is completely trivial. Right? That still seems like logical nihilism to me. So when I talk about the view logical nihilism, I mean the view on which this is what the form of a logical law is, and nothing like that holds. Right? So there are always going to be counterexamples to any set of premises and conclusion. Second question, not just what do logical laws look like formally, what does it take for one to be true? Right? There are various different views on this as well. So usually a textbook will just pick one and adopt that view. And the literature on logical pluralism usually speaks as if a certain approach is correct, but there is some controversy, and it would result in different conceptions of logical nihilism because you have different conceptions of what a logical law is. So let me just sketch like 3 possibilities here, and then I'm going to pick one for the rest of the talk. So one possibility is what I'll call the cases approach to logical consequence. It's the approach that you find most in sort of Beale and Rastall and Graham Priest talking about logical pluralism. And they say gamma entails phi just in case, in every case where every member of gamma is true, phi is true as well. Right? There's one version of that talks about possible worlds. And that gives you a version that you often hear in like intro logic classes, or you might often hear in philosophy, that gamma entails phi just in case there's no possible world in which every member of gamma is true and phi is not. In practice, when people are doing logic, they quickly move beyond talking about possibility and they talk about models. And there are all kinds of reasons not to equate models with possible worlds. But the cases approach and the possible worlds approach are sort of on the same spectrum of interpretations of this symbol. Okay, so if that's what a logical law is, it says that there are no cases in which every member of gamma is true and phi isn't, then logical nihilism says that for any set of premises gamma, and for any conclusion phi, there's some case in which every member of gamma is true and phi is not. So that's what the view would amount to. Right? Pick any argument you like. There's some case in which all the premises are true and the conclusion is not. But there are other ways of thinking about logical consequence, and there's one that we find in Tarski. And we often talk as if we're using Tarski's conception when we talk about logical consequence, and you find it in Quine as well. And that's the thought that what this says is that for any interpretation of all the non-logical expressions in gamma, so the predicates and the names, and in phi, there's no interpretation of those non-logical expressions that makes every member of gamma true and phi not. So then you could think about something like phi and psi as you're going to give them interpretations. Maybe those would be like meanings in some rich sense. Presumably if you're doing sentential logic, you're going to be giving them truth values of some kind. If you're doing first order logic, you're going to be giving them extensions to predicates and reference for names or something like that. But some kind of meaning that you're assigning to these expressions. And then the question is there any way to assign meanings to the non-logical expressions in this and this, such that this comes out true and this doesn't? All right. Actually, we only need two different ways of thinking about these laws, so I'm just going to stick with those two. And in fact, I'm going to pick one version to be going on with, right, which is this interpretations approach. So given the stuff that I have said so far to persistify logical pluralism, right? It's the view that there are no principles of this form, where you have a set of premises on the left-hand side, conclusion on the right-hand side of the turnstile. Or when you have principles of this form, you can always give some interpretation of the non-logical expressions that makes everything in gamma true and phi not true. So why would anybody think that? Well, one thing that it's really important to realize is that you need to have a rich enough conception of interpretations in order to guarantee even counterexamples to principles that we think are obviously incorrect. So here's a principle that I take it just about everybody thinks is incorrect. It's affirming the consequent. All right, so this is a famous fallacy. If phi then psi, psi, therefore phi. Right? So you've got the phi and the psi the wrong way around. It's not modus ponens. It looks officially like it. Now, suppose that we think that interpreting the non-logical expressions in here, so that would be phi and psi, is a matter of assigning truth values to them. But the only truth value we have available to assign to these sentences is true. Well, if the only thing you can assign to phi and psi is true, then of course phi has to come out true. That's the only available interpretation. And so you won't be able to get a counterexample because there's no interpretation on which this gets anything other than true. Right? So that would be a stupid set of interpretations to have. Right? Because it seems pretty clear that sentences, they're not all true. Right? Some sentences are false. So you probably want to have two interpretations at least open to you for sentences. You want to say, okay, this could be true or this could be false. And when you do that, you find you can get a counterexample to this principle. You can say, okay, let's have phi be false and let's make psi true. And that makes that true. And then you remember from your logic class that conditionals with a true consequent come out true. So now we have the two premises true, but the conclusion false, so we got a counterexample. But you could have this doubt, right? You could think, okay, so now we've got interpretations on which affirming the consequent comes out not valid, but do we have enough interpretations available? Like maybe there are some other principles for which we haven't been able to find counterexamples yet, and if we just had more interpretations available, we'd see that there are interpretations on which the premises all come out true and the conclusion doesn't. So, for example, if you're a strong cleaning logician, you look at something like the law of excluded middle, phi or not phi, and you say, well, the classical logician claims this always comes out true, no matter how I interpret phi. Right? They say, I can interpret it as true, I can interpret it as false. If I interpret it as true, then not phi comes out false. If I interpret it as false, then not phi comes out true. And either way, the disjunction comes out true. And the strong cleaning logician says, yeah, but you've missed an interpretation. What about the interpretation on which phi gets neither? So I allow phi to be neither, and then not phi is neither as well, and now the disjunction is neither, and look, here's an interpretation on which this doesn't get true. So this is not valid after all. And we say, oh, right, it turns out that the law of excluded middle is not a law of logic once we look at a broad enough set of interpretations. Are we looking at a broad enough set of interpretations now? Well, of course, the paraconsistent logicians say no, right? So the strong cleaning logician maybe motivated their point by talking about vagueness or talking about reference failure. They'll have some philosophy to give you, some philosophy of language. And they will argue that there are some sentences that have no truth value. Right? The dialetheist, the paraconsistent logician, is going to say, yeah, it turns out there are some sentences that have two truth values. They are both true and false. And you say, that's ridiculous. How could any sentence be both true and false? And they say, well, look at the liar paradox. If you think about the liar paradox, it's really hard to find a solution. The things that people say are solutions are really, really complicated. So complicated, they're probably not right. The best solution to the liar paradox is to say that the paradoxical sentence is both true and false. That's a pretty weird sentence. So, if you haven't thought about the liar before, the sentence that says this sentence is not true, right? You can give an argument that it's true and an argument that it's not true. And the paraconsistent logician wants to say, yep, that sentence is both true and false. Okay, that the arguments are both right. And if they're right about that, then we need to add a fourth truth value. In addition to true and false, we need to add both. And when we add both, we can find counterexamples to other principles. So for example, this principle from phi and not phi, you can get anything you like. So ex falso quod libet, or paraconsistent logicians often call this explosion, because as soon as you've got a contradiction, you get everything, it just explodes with consequences. And they say, okay, suppose that phi is both, and they tell you, because they have a truth table for this, the negation of something that's both is also both. Well, then you have two premises that are true, because both is a way of being true, you're just true and false. But this conclusion is anything, right? So it might be a false thing. Suppose it's 2 plus 2 equals 5. Then you would have false here. And now you have an interpretation on which all the premises get true, but the conclusion doesn't. So counterexample to another logical principle, by expanding what we count as an interpretation. All right. If you accept both of these expansions, right, so the strong clean addition of no truth value as an interpretation, and the paraconsistent addition of both as an interpretation, it gives you a really weak logic. Like, I think it's, there are some decision points here that you could make about how to do your truth tables and exactly how to set things up. But it's fairly plausible that you would end up with a logic like FDE, the logic of first degree entailment. That loses a lot of the things that people care about in logic. So you don't have any logical truths anymore at all. You don't have modus ponens, you don't have disjunctive syllogism, you don't have explosion. What do you have? Well, you have some of the trivial things that the logical pluralist said, well, okay, maybe you still have these things, but you have practically nothing, right? So you still have conjunction elimination. So from the conjunction of phi and psi, you can get phi. And you still have identity. From phi, you can get phi. So what I'm going to try to do now is give you a reason to think that there might be interpretations that would lose you these as well. Right? The even identity would fail, and though I won't have gone through every possible FDE principle, I hope it's plausible that if conjunction elimination fails and identity fails, that there's nothing left. Right? So here's the thought. How do you get counterexamples to something like conjunction elimination? Because it seems once you've made this true, once you've made this true in particular, well, then this is just going to be guaranteed to be true. Right? You've already stipulated its truth value, and you can't make a conjunction true without making both conjuncts true. Similar thoughts with identity, but what if there were some expressions that changed their truth value depending on whether or not they were embedded in other expressions? So, for example, a sentence that changed its truth value depending on whether it was embedded in a conjunction or whether it appeared on its own as just an atomic sentence. So, let me call this weird sentence embed, right? Right? Embed is syntactically a sentence, right? So you can plug it into the left-hand side or the right-hand side of the conjunction. It can appear on its own as a sentence. And it's true if it's embedded in a conjunction like this, but not if it appears on its own, unembedded in some conjunction. So if we take an argument that says embed and now I can just put anything in here, so psi, therefore embed. Here, it gets to be true because it's embedded in this conjunction. Here, we can assume psi is true, so we have a true conjunction. But over here, embed appears on its own as an atomic sentence, and so it's going to be false. Just stipulating. So now we have a situation in which the conjunction comes out true without the conjunct coming out true on its own. It's kind of a weird sort of expression, but it doesn't seem impossible. Right? It's a certain sort of context-sensitive expression. Right? So we're used to expressions that change some part of their meaning depending on the context. What's a little unusual about this one is the context that matters is linguistic context. Right? It's not who's speaking or what day it is or what time it is. It's what sort of construction it fits into. Okay, but I bet if I can do this for conjunction elimination, I can also do it for identity. So there might be some sentence prem, and prem is such that it gets the truth value true anytime it appears in the premises to some argument, and not otherwise. So if it appears in the conclusion to an argument, it automatically gets the truth value false. So then here it's true, here it's false, but it's the same expression. So counterexample to identity. All right. So there is one reason you might want to be a logical nihilist. It's because you think language can be really, really rich And the more expressive and the richer you make the language, the more interpretations are available for the non-logical expressions in an argument like this, and the more counterexamples you find. Okay. So, my last question, and the last section of this talk is, what do you do about this? Right? It seems like there are two obvious ways to go. One is you're like, hurrah, no logic, right? Get rid of logic, that's it, right? If you like logic, right, and I kind of like logic, that doesn't seem like a very satisfying way to go. Another thing you might do is you might say, look, there's just got to be something wrong with these counterexamples, right? They're kind of mixed up, they're confused in some way. You might try to say that this is not an admissible interpretation for the non-logical expressions in an argument. Right? So maybe you think you're not allowed to have interpretations that give different values for different linguistic contexts. Right? Or maybe you're not allowed to have interpretations, if you want to protect some of these other argument forms, maybe you're not allowed to have interpretations for vague expressions, or you're assuming that there has to be reference for everything, or for some reason, right, these interpretations don't count. We want all interpretations of a certain sort of well-behaved kind. One of the issues that bothers me about this kind of approach is it seems a bit ad hoc, right? It seems like we restrict what we count as an interpretation in response to some kind of funny, tricky counterexamples. When people do things like classical truth-functional logic, we just sort of stipulate that we are dealing with a certain kind of simplified language in various ways. So we say, all our connectives are going to be truth-functional, and our sentence is going to have two possible truth values, and if we move up to first-order logic, we say every name has to have a referent, and they are simplifications in some way, right? They make the logic a good deal easier to do, but we're often just not thinking about more complex kinds of language. So particularly we're not thinking about importing semantic expressions into the language, or adding vague predicates, or anything like that. And it seems odd to think that the conception of interpretation that people had in mind right from the beginning in thinking about logic was something that explicitly ruled out this kind of thing. Okay, so here's a third possibility. And I'm going to kind of get at it by talking about Lakatosh on geometry. All right, so Lakatosh's book, Proofs and Refutations. We are in a geometry class, and the class is trying to come up with a theorem about polyhedra. So cubes and tetrahedrons and stuff like that. And they come up with this hypothesis, this is Euler's theorem, that the number of vertices minus the number of edges plus the number of faces always equals 2. And if you try this out on some really simple polyhedra, you'll find that it works. So I am very, very bad at drawing three-dimensional shapes, so just give me a second to attempt one. Try to make it look a little bit like a polyhedron. All right, there's a little tetrahedron, right? I won't even go near a cube. And the question is, does the number of vertices minus the number of edges plus the number of faces equal 2? Well, vertices, you've got 1, 2, 3, 4. Edges, 1, 2, 3, 4, 5, 6. Plus the number of faces, 1, 2, 3, and 4. So 4 minus 6 minus 2 plus 4 is 2, right? Okay, so it works for this one, right? And the conjecture is it works for all polyhedra, right? If we draw a cube, if we draw a dodecahedron, or all kinds of complex three-dimensional shapes, this still holds. And the class come up with a proof of this theorem, right? The proof is kind of fun, just the beginning part of it. What you have to do is you imagine that the polyhedron is like made out of a rubber sheet. So it's hollow inside and it's made out of rubber, right? And then you take a knife and you cut out one face of the polyhedron and like throw it away. And then you take the rest and you stretch it. This is why it has to be rubber, right? You stretch it flat on a plane. right? And then you have to do some stuff to it. You cut out triangles, and it becomes obvious that the original thing you started with must have satisfied this formula. So we got a sort of conjecture, we got a proof of the conjecture, successful mathematics, right? It's done. That should be the end of it. Except it's not, right? So in the class, various students begin to suggest counterexamples to the theorem, a thing that's been proved, right? So one example is you have nested cubes, like one cube and then a little cube inside of it to create this like three-dimensional shape. And it turns out when you count the vertices and the faces and the edges, you don't satisfy this theorem anymore. There's a picture frame counterexample that doesn't work either. And so we're in a very, very strange situation in which we've got a theorem, we've got a proof of the theorem, and we also have counterexamples. And there are two students that take a stand on what we ought to be doing. Right? So one of the students says, one counterexample is as good as 10. Right? Hands up, you failed. We've refuted our geometrical theorem. Right? That's like the logical nihilist. Right? They're like, give up. And the other student says, well, we've got these counterexamples and we've got the theorem, but the theorem is beautiful and the counterexamples are weird. Right? The counterexamples are, he calls them monsters. And he said, it's not the theorem that should retreat, it's the monsters. Right? And so he begins to say that these weird counterexamples don't fit the definition of polyhedron. So that it was not obvious what the definition of polyhedron was right from the beginning. And so he has to start sort of generating definitions of polyhedrons. And every now and again there's a new monster that comes up that isn't ruled out by his definition. So he has to change it again. And he's sort of changing it ad hoc in response to these counterexamples. And he wants to suggest that this is what people meant by polyhedron all along. But that's not that plausible, given that they hadn't really even been thinking about these kinds of cases. They started out thinking about the tetrahedra and the cubes and things like that. So Lakatos says, you shouldn't do either of these things. You shouldn't throw out the theorem, and you shouldn't ignore the counterexamples. You should do this thing called Lemma Incorporation. Okay. So Lemma Incorporation is this. You go to your proof of the theorem, and you figure out what assumption you made in your proof that the counterexamples violate. Right? And when you find out what that is, you build that assumption in explicitly, so that now the theorem only applies to things that fit that assumption. Right? So it's not that you change the theorem in this sort of totally ad hoc way, right? You have to go and figure out what it was, and this might be non-trivial work, about the counterexamples that created the trouble, and then build that assumption in explicitly. And one of the things this does is it gives you a restricted domain in which the theorem still holds, so you don't have to get rid of it completely. But it also allows your counterexamples to do the work of showing you how to restrict that domain, and you can start asking questions about the counterexamples, like, well, what is this number, or this number, for these counterexamples? And are there patterns in how these numbers are generated, depending on what the counterexample looks like? So that you get more fruitful geometry out of this approach, rather than just either giving up or sort of just ad hoc changing your theorem. Suppose you do this in logic. Right? So take a theorem which has like a slightly more substantial proof than just identity. So for clarity of example, let's take the law of excluded middle. So standard counter model theoretic proof says, okay, so you've got this sentence phi, it's going to be either satisfied or not satisfied by some model. If it's satisfied by the model, then this whole thing is going to come out true, like this is true in the model, so this is true in the model. But if it's not true in this model, then if it's false in the model, this will come out false, this will come out true, and again the whole thing will come out true, so in every case, the whole thing comes out true. And then we get our strong Kleene sentences, the kind that generate the counterexamples to the law of excluded middle, so sentences that would get the truth value neither. And you say, well, what assumption did these violate that was used in the proof? Well, the proof assumed that the sentence was either going to be true or false. But this sentence doesn't satisfy that. It's neither, right? So maybe what your theorem has to say is something like, for sentences that can only be true or false, phi or not phi. Right? So maybe you would make that more succinct, say, for all bivalent sentences, phi or not phi. And that might mean that you could keep something like the law of excluded middle for a restricted domain. So suppose you thought that in arithmetic, every sentence was true and false, or true or false, right? But not neither, right? Well, then you might think that you're perfectly entitled to use the law of excluded middle when you're doing arithmetic, right? When you're using the language which is such that every sentence has to be true or false. But you might still think there are richer languages that allow you to have sentences that are neither, and then you would deny that this holds for those richer languages. All right, if you do that, here's how I think you deal with that original argument for logical nihilism. You're basically denying this, right? You're saying, no, things can be principles and logic without holding completely generally, right? So, for example, we only get the law of excluded middle by restricting to languages which are bivalent, right? We only get the principle of non-contradiction by restricting to languages that, say, don't have a truth predicate or don't have a certain richness. They don't allow you to construct a paradox. Or we only get identity when we don't have these really funny context-sensitive expressions. Okay? But you still get to use these things in various circumstances. And if someone were to say to me, like, you don't understand what a law of logic is, right? Because you think that laws of logic can be restricted to particular kinds of language or to particular kinds of expression. Laws of logic are supposed to be completely general. I'd say if you insist on that conception of a law of logic, then there aren't any laws of logic. But why would you do that, right? If you were doing physics and you initially thought that all physical laws had to be deterministic, they had to tell you exactly what was going to happen at time t4 given what had happened at time t1, then, and then it turned out that you couldn't find any deterministic laws, although there were lots of good indeterministic ones, right? Should you throw up your hands and say, no, physics is impossible, you guys don't know what physical laws are? Well, if you're doing physics, you're presumably interested in predicting the physical state of systems, given what it was like before. And if you're interested in logic, you're presumably interested in capturing patterns of truth preservation. If it turns out that none of those patterns of truth preservation are completely general, but there are still all kinds of interesting uniformities and patterns that can be described, then you describe the interesting patterns and uniformities that there are. And if they turn out not to be completely general, then that's just fine. Okay, thank you very much. That's it.
We have about 15 minutes for questions, so I'm waiting. Yes?
So I have a question about the explanatory power of logical nihilism. When I did introductory logic, we talked about like deductive valid arguments are truth preserving, but inductive arguments can only be strong but not guarantee the truth. I guess logical nihilism will have to reject that.
I think what you're going to get is that truth can be guaranteed given certain assumptions or for certain languages, right? So if you're doing arithmetic and you accept that sentences in the language of arithmetic can only be true or false, right? And you think that this principle holds for sentences in the language of arithmetic, then you know that this has to be true, no matter what sentence in the language of arithmetic you write in there. So you still get a guarantee. And if modus ponens holds there as well, then you know that if you've established some conditional and also the antecedent of the conditional, you are guaranteed the conclusion. The thing is, there's a step beyond that, which is saying not just that this works with that language, but this works with any language, no matter how rich. And you're no longer saying that, right? But you're saying, restricted to at least this language, you get a guarantee of truth preservation.
So in that second line, the second line, so not true that phi and not phi.
Okay.
I was thinking about that classical expression, the King of France is bold. So the King of France is bold, I think should be true. And not bold also would be true, since so an empty set always belongs to any set. So that would be true and true. So the result would be false. So a Lemma Incorporation, should we demand that we discount the empty sets?
Okay, so some of this is going to depend on your semantics, right? So some people think the King of France is bald is just false because there's no King of France. Some people think that it has no truth value because there's no King of France, and you apparently think it's true. So it's going to depend on exactly what the best theory is of empty definite descriptions like that and sentences that attribute predicates to them. But if your theory turns out to be the right one, such that this is an example of a sentence, right? So I write in the King of France is bald here, and also the King of France is bald. You think they, oh no, here and here, right?
The second line,
Yeah. And so this turns out to be true, and if you think its negation is false, then you're going to think you've got a counterexample to the principle of non-contradiction, right? So Graham Priest would love that, I think, right? So he thinks that there are true contradictions. Actually, I don't know whether you particularly like that one, but yes. So it would be a step further towards logical nihilism, and it'll give you a reason to give up the principle of non-contradiction because you think there are circumstances where, the negation turns out false.
But we would just say, okay, without excluding the case of an empty set, then this would always be true. We should exclude, maybe.
Yeah, so if you were gonna... There's a thing that people do in classical logic, standardly, right, where they say any singular term has to have a referent, right? And if you think definite descriptions should be interpreted as singular expressions, then they're going to insist that you assign it some referent. But you might think that English is not like that, right? That we have these singular terms that don't have reference. And so if we want a richer language that's more like English, we should drop classical logic and figure out the logic for this richer language. Presumably it's going to be some sort of free logic. And yeah, you're not, certainly the way you're thinking about it, you're not going to get certain laws of logic, but the classical editions do.
So in the new mathematics of homomorphic type theory, that demands tokens, that demands that it has at least one element, that would always be true.
Okay.
You had a question, Charles.
Do you have any examples of pred or med?
This was actually supposed to be the example. So I was introducing you to a new linguistic expression, right? So much the way you might introduce somebody to top or bottom when doing like truth functional classical logic, and you say, this is always true, this is always false, right? Well, this is a sentence that is true in these circumstances and false in these circumstances. There's then this question about, are there any English sentences that you would translate with something like that? I'm not sure. So I've definitely heard people give attempted examples. And they're often things like, this is the first time I've used this sentence in this talk. Therefore, this is the first time I've used this sentence in this talk. Which, at least superficially, the two sentences are syntactically the same. And so there's a question about whether that's been kind of uniform substitution into identity. So a lot of arguments happen at this point about the this and the referent of this in the argument that I just gave, because one thing the classical edition or the objector can do is say, well, you didn't preserve meaning between the first instance of that sentence and the second instance of that sentence, and so this doesn't count as a counterexample, it's not really identity. But that's like the closest thing I've heard in just English. I think there's a lot to fight about with that example, which is one reason I used an artificial example. But I think that's where you go.
Does that go for the same for embed and also the modus ponens one that you talked about potentially it could be something more complicated? It's very hard to come up with an actual example.
Okay, so modus ponens, Graham Priest thinks he has actual counterexamples, and they use the liar sentence. So they use this sentence is not true, or equivalent sentences to that. And, as part of his response to the liar paradox, that sentence gets assigned both. And then you get a counterexample to modus ponens by making this false and this both. And so this is both and this is false. And the way his truth tables work for the conditional, if this is both, then it's true, and you have a true antecedent and a false consequence, so the conditional is false, but it's also true because you've got a false antecedent and a false consequence. So the conditional gets both, and now you have two premises that are both and a false conclusion. So counterexample to modus ponens, where you've substituted this sentence is not true for phi and any false sentence you like for psi. So he does think you can get a counterexample with, if you like, ordinary English.
Yes,
yeah, unfortunately for me, whenever arguments are reduced to letters of the alphabet, my brain doesn't work. Fortunately at school I had a teacher who knew that I couldn't do higher maths at Oberlin. He said, no, he said immediately, he didn't have to think twice. He said, no, you have to go to ordinary maths. But anyway, I have one question. What colour is grass when it's covered by snow?
That is an interesting question. So, not speaking as a philosopher, but just my intuitive response is to say that it's green. Right? You don't think that's right?
No.
Okay.
Is black a colour in the absence of light?
I don't know.
Well, obviously, colours to me are denominators of light. So in the absence of light, there can be no colour.
Okay. Okay, suppose you're right. Okay. I think I can still use... You know what? In order to give some examples of modus ponens that people find kind of compelling, sometimes all I need is some sentence that people think is true. And I tend to use, like, snow is white and grass is green. But obviously, if you do philosophy, there are all these skeptical arguments about lots of different things. And that's going to include things like snow is white and grass is green. And I assume if you do a lot of philosophy of color, then these seem like ridiculously simple things to say, and they might not be true. But I don't need those sentences. I just need some sentence that you think is true. Right? So I guess I wonder whether you'd be happy with 2 + 2 = 4?
Not if the two things are different.
Okay, all right. I might have to think about it, but...
You have to say, what do they have in common? Just the number 2. Otherwise, they have nothing in common.
Okay. In that case, I might have to, hand it over to you to come up with something that you think is true.
I think, this is what I think. Every act in the universe of the physical nature is true. That is true. I lifted my hand. There's no dispute. You can dispute it if you like. I can't.
Okay.
So every act in the universe is true. The problem humans have is they try to make truth out of the impossible.
Yeah.
All right, I will think about that. Thank you.
You got a question on the back, yeah.
I guess I'm kind of concerned that you haven't provided independent grounds for accepting that Prem is a counterexample to identity. You seem to maybe be taking.
Okay. So I'm wondering what kind of thing would count as independent grounds. Are you thinking if I discovered it in some natural language, people were using it? Or would I have to like describe some theory in which it would be a useful expression to use?
I'm not sure.
Yeah.
It just
So really,
seems kind of doubtable that such a thing could be. And when you see that example is really a forceful argument against identity.
okay. Yeah, so, I mean, the way this works is that I have made up a sentence, right? And then I've told you, sort of told you how it works intuitively, right? That when it appears in the premises to an argument, it's true, and otherwise, especially when it appears in the conclusion, it's not true. It seems to me that that's kind of a possible expression, like that we could introduce it to English. Whether or not it would be useful doesn't seem super important to me, so much as whether it would make sense. Like whether that's an addition you could make to a language, you could define it and add it in, and then sort of use it consistently in the sense of, sensibly and uniformly over time. And it seems to me that you could, right? And it definitely seems to me that there can be expressions that are sort of sensitive to linguistic context. I mean, I'd have to think about some good ones, but so I think all I need is that the expression makes sense, right? And then once it's in the language, I don't have to use the truth preserving anymore. So here's one thing maybe I could do. I don't know whether this would satisfy you, but I could set up a formal model theory for it. So I could describe the interpretation. So if I were doing classical logic, I'd say an interpretation is a function from the atomic sentences in the language to the values true and false, right? And if I'm giving you a strong Cluny interpretation, I add in an extra value, namely neither, and there are truth tables for extending that to the rest of the language. And then for this one, I have to say, well, that function is not just going to be a function from the sentence, but a function from the sentence and its linguistic context. So presumably the two important values are embedded in the wider context and just appearing on its own. And when it's embedded in a wider context, this is the value it gets, true. And when it's not embedded in a wider context, it gets the value false. That's a coherent function that I can then extend to the rest of the language. So I think I can describe a model theory for this language, and then I have a logic in which identity fails. Not satisfied? Okay, all right.
Let's take one last question. Yeah, go for it.
Okay. One thing I wondered about is if you say that in your logic of the system, like for example, if phi and psi does not entail phi or phi, and then so that conjunction elimination fails. In what grounds would you say that in that kind of logic and that kind of formalism, like the upside pointing B still stands for conjunction, it's not just a meaningless symbol?
Yeah.
How do you make a claim that conjunction elimination might fail? Because it seems that in that kind of language there's no conjunction at all involved. And whenever there is conjunction, consensually conjunction elimination works.
Yeah, so every time somebody extends the interpretation function on the atomic sentences, they've got to say something about what happens to complexes built up out of them, right? So they have to say more about conjunction than just the classical logician said. And usually that thing seems sort of intuitive or reasonable. So the strong Cluny logician says if they're both neither, then the conjunction gets neither, and if they're both false, the conjunction gets false. And it's clearly like an extension of the original function. So it feels like there's some grounds for calling that conjunction. But even in the embed case, like what varies is the truth value of this atomic part depending on the context. So it's your initial interpretation function that's going to be sensitive to linguistic context. And then your truth clause for conjunction can say the same thing as it always said, which is that the truth value of this is true just in case both of these are true. And that, think that's enough in common.
Yeah, I think I was thinking about logical terms more in syntactical terms, and you of course, bring in semantics, you can presumably say what they have in common with conjunction.
Yeah, I think that's the other way people go when they try to make conjunction elimination false. They want to introduce some other conjunction that's, emits of a weaker law. The reason they don't want to do that is first, people are like, you changed the subject, right? That's not what I meant by conjunction. And secondly, you still get another law, just a weaker law, right? So my thought was, instead of messing with the meaning of conjunction, we'll imagine that phi and psi have really weird meanings and really weird interpretations and try to get it that way.
Yeah, unfortunately, for the sake of time, we can't go further and have to open the lecture here. Professor Russell is lecturing tomorrow at the University of St. Andrews, so all those who are interested in following some lectures, you know it now.
There's a different token tomorrow.
Oh, yes. But yeah, kindly join me in thanking Professor Russell for that.